Welcome to this explainer. Today, we are diving into the absolutely massive financial and environmental stakes hiding right inside the industrial machinery sector. When we think of heavy machinery, we're talking earth-moving equipment the size of a 3-story building or industrial pumps that can literally move rivers. It's super easy to just focus on the brute force and the immense scale of the products themselves. But there is this fascinating, high-stakes life cycle happening just beneath the surface, and it's heavily tied to ESG risks. So we're going to break down this complex life cycle today and see exactly how industry leaders are navigating it.
To kick things off, consider this for a second. What hidden financial vulnerabilities are locked inside a massive industrial turbine before it ever even powers on? It's a pretty provocative question, right? Because we tend to think the risks associated with heavy machinery begin the exact moment the engine starts burning fuel. But the truth? Severe financial and operational risks are completely embedded in these products way before they are ever used, and those risks carry all the way through to the absolute end of the product's life.
Okay, let's dive into the circular journey. Our roadmap for this explainer covers 4 key stops. First, the machinery lifecycle risks. Second, sourcing critical materials. Third, fuel economy and emissions. And finally, the remanufacturing opportunity.
Starting off with Section 1, the machinery lifecycle risks. We are looking at this through a strategic business lens. To really wrap our heads around this business risk, we need to map out a conceptual timeline. And listen, this isn't just about compliance. This is about how exposed a company's cash flows and cost structures are to external shocks, from sudden material shortages all the way to shifting regulations. So, imagine a massive turbine. Its life cycle is broken down into 3 major steps. Step 1 is material sourcing, where the raw components are extracted and procured. Step 2 is the use phase, where the equipment is actually out in the field doing its job. And Step 3 is remanufacturing, which is the end-of-life rebirth of the product. This circular timeline is going to be our guide for today.
Moving right along to Section 2, sourcing critical materials. This is where our supply chain begins.
Let's orient ourselves on our life cycle map. We are right here at Step 1, at the very beginning of the supply chain. Now, obviously, before a machine can be assembled, manufacturers need huge amounts of raw materials: steel, plastics, rubber, glass. But more importantly, they rely on highly specific, critical materials that form the advanced technological heart of modern industrial goods.
We're talking about elements like cobalt, rare earth elements like neodymium and dysprosium, platinum group metals, antimony, and tungsten. And you can't exactly just dig these up in your backyard, right? They are absolutely essential. You simply cannot build certain high-efficiency motors or advanced components without them. So what's the problem? Well, there are very few available substitutes for these materials, and they are subject to intense global competition. When everyone in the world needs the exact same rare elements, the risk of supply restriction absolutely skyrockets.
It's a massive strategic balancing act. On one hand, you've got high financial exposure. When materials are sourced from just a handful of countries, it exposes manufacturers to severe geopolitical uncertainty, hard physical limits on availability, and some wild price volatility. But how do they fight back? Well, they mitigate those risks through strategic actions. Things like diversifying their suppliers, physically stockpiling materials, pouring research into alternative substitutes, and investing heavily in recycling technology. The companies that manage this balance effectively, they're the ones that insulate themselves from massive supply chain disruptions.
All right, on to Section 3, fuel economy and emissions. This is where market and regulatory risk takes center stage.
So let's fast forward a bit. The machine has been built and sold, bringing us to Step 2, the use phase. The financial risks now transition completely from the supply chain directly into market share and regulatory compliance. This is the period where the machinery is out in the real world, actively burning fossil fuels and releasing greenhouse gases. Customer demand for energy efficiency is rising sharply right now, and at the exact same time, government regulations restricting air emissions are tightening globally.
To measure their exposure to these regulatory risks, companies use highly specific metrics. Take fleet fuel efficiency, for example. This is defined as the average fuel economy of a company's medium and heavy-duty commercial vehicles weighted by the number of each unit sold. It's a crucial metric because it tells investors exactly how efficient the company's products are in aggregate, which directly correlates to their readiness for future emission standards. But here's the catch. Industrial machinery is a wildly diverse sector. I mean, think about it. You can't measure a stationary generator the same way you'd measure a semi-truck. They require completely distinct measurement standards. For medium and heavy-duty vehicles moving freight, the metric is liters per 100 ton kilometers.
For non-road equipment, like an excavator, it's simply liters of fuel consumed per hour of operation. And for stationary generators, it's calculated as kilojoules per liter. These tailored metrics allow companies to accurately gauge their operational efficiency across some drastically different product lines.
What's really interesting here is how rigorously quantitative these industry standards are, especially in that fuel economy and emissions category. By tracking these highly specific numbers, whether it's particulate matter, nitrogen oxides, or fuel efficiency, companies aren't just filling out paperwork to keep regulators happy. They are actively reducing their regulatory risk and heavily improving their brand value in a market that increasingly demands cleaner, more efficient solutions. Which brings us to our final section, the remanufacturing opportunity. This is a massive strategic pivot.
We've talked a lot about risk so far, supply chain risk, regulatory risk, but this final step, remanufacturing, it is entirely about a massive strategic opportunity. We've arrived at the final step of our circular timeline. The use phase is over, the machine is worn out, but instead of heading to a scrapyard to rust, the product is systematically collected for a second life.
Now, I want to be super clear about what we mean here, because the standard is incredibly strict. A remanufactured product is an end-of-life component that has undergone an industrial process to be returned to its original working condition. We're talking like new. Actually, scratch that. It's not just basic recycling where you melt down steel, and it's definitely not just patching a broken part. It is a complete ground-up industrial restoration of the system.
But practically speaking, how do companies actually get these massive heavy machines back from customers? Well, they use some pretty ingenious take-back mechanisms. Step 1 usually involves equipment servicing or exchange programs. Step 2 introduces a clever financial incentive, dealer deposits for used parts, which the industry calls cores. Think of it literally like a bottle deposit, but for a massive multi-ton engine block. And Step 3, the refund is issued to the customer when that core is returned within a specified time frame. This brilliant setup guarantees a steady stream of raw material returning directly to the manufacturer.
And this is exactly where we connect the dots right back to our very first step. Remanufacturing limits the demand for virgin raw materials like steel, iron, aluminum, and industrial plastics. By reusing these end-of-life cores, companies dramatically decrease their manufacturing costs and the time required to produce finished goods. Plus, it creates entirely new sales channels and revenue streams. This whole circular process beautifully insulates the company from those initial material shortages and price volatilities we were talking about earlier.
Which leaves us with this final thought to ponder. How will closing the loop with remanufacturing ultimately define the future market leaders in the industrial machinery sector? The companies that can master this continuous circular life cycle, securing critical materials, innovating for efficient use phases, and executing massive remanufacturing operations, they're building the ultimate competitive advantage. They aren't just mitigating ESG risks, they are turning them into highly profitable opportunities. Thank you so much for joining me for this explainer. I really hope it changed the way you look at heavy machinery. Keep learning, and I'll catch you next time.